Hi everybody, it's Mr. Barbier back with another video. Today's topic is solving a division problem using long division. Let's get right into it. So, as it says here, let's find out how to solve a division problem using long division. The memory aid below will help you to remember the 5 steps of long division. Each of the letters below, D, M, S, CB, represents one of 5 members of a family. They also stand for each of the 5 steps for long division. Use these 5 steps to guide you through solving a long division problem. Let's take a look at the memory aid first. So the memory aid you see here, very similar to, for example, the memory aid for order of operations, also known as PEMDAS, right? Please excuse my dear Aunt Sally. That's the memory aid for order of operations, also known as PEMDAS. But the memory aid for long division are the 5 members of a family. Instead of a sentence like, please excuse my dear Aunt Sally, each of these 5 letters represents a family member. So D stands for dad, right? Or you can say, dad stands for D, mom stands for M, sister stands for S, cousin stands for C, and brother stands for B, right? So if you can remember dad, mom, sister, cousin, brother in this order, okay, then you can remember the steps for long division. Divide, multiply, subtract, check, and bring down. And notice that after we do these 5 steps, we repeat the process. Okay? You do these 5 steps and repeat. Again, these 5 steps and repeat. So use this memory aid, dad, mom, sister, cousin, brother, to help you remember the 5 steps for long division. Okay? Divide, multiply, subtract, check, bring down. And then, of course, repeat the steps. So, we are going to look at some examples right now of how to do long division, and we're going to use these 5 steps when we do the problem, okay, or when we do each problem we're attempting today. We're going to use these 5 steps, okay? All right, so let's get right into it. All right, here it is. So we have example 1 and we have example 2, all right, and I've written them right here. Now, first thing I want to do, ladies and gentlemen, is I want to write my 5 steps for long division along this red margin on the left side of the margin, okay? That's what I want to do first because my steps are what guide me, okay? The steps are my guide. So let me just zoom in. And along this red margin, please follow along with me. I'm going to write the steps using the memory aid. So the memory aid is dad, mom, sister, cousin, brother, right? So I'm going to write that same thing. I'm going to write D for dad, M for mom, okay? S for sister, C for cousin, and B for brother, okay? That's the memory aid. Right? Now let's write what each letter stands for in terms of math. Dad, D, stands for divide. So put the division symbol. M stands for multiply, mom, multiply. S, sister, stands for subtract, subtraction symbol. C stands for check, so I'm just going to put a little check symbol. And B stands for bring down. Okay, those are my 5 steps. And then at the end, of course, we repeat. So I'm going to draw this arrow to show repeat. Okay, let's use these 5 steps to solve this problem. So first things first, ladies and gentlemen, I cannot solve a division problem written this way, right, with a division symbol. I must rewrite the problem using a division house, what I call a division house. So let's do that. So I'm going to make a division house like this. Let's do it this way. Okay. All right. Now I skipped a couple of lines because I need this space here to put my answer on the roof of the house. All right. And this is very important, ladies and gentlemen. I always hear this, Mr. Barbier. The big number always goes inside, right? That's how it always is. The big number is always inside. That is not necessarily the case. It's not the case in all situations. Do not get used to always putting the big number on the inside. So what I tell students is, can you divide a small number by a big number? For example, could this number, 6,830, could this number be 1 instead of 6,830? 1, in other words, divided by 5? Could you actually do that in math? Yes, you can. Okay? You can divide a small number by a larger number. It's just that when you do that, you get a decimal answer instead of a whole number. All right. So please don't get accustomed to saying the big number is always the number inside. No. Say it this way. The dividend, which is always the number that comes first in a division sentence, right? Or division problem. The dividend is always the number that goes inside. And in this case, this is my dividend in this problem. So we're going to put it inside, right? We don't need the comma, just put 6830, okay? And put the divisor, which is the 5, on the outside, okay? Notice something. You say 6,830 divided by 5 written this way, and guess what? You read it the same way this way. Do not say, oh, Mr. B, this is 5 divided by, no. This is 6,830. You say the number inside the house first, 6,830 divided by 5. This is read the same way as this. You read this left to right, but you read this inside out, okay? 6,830 divided by 5. You don't read, when it's written this way, you don't read it from left to right. No, you read it from inside the house, out the house, okay? Just like you do, so this is read the same way as this. These two are not read any differently, okay? All right, let's follow the steps. So we are going to go in this order, all right? And we're going to divide. Unlike with multiplication, in multiplication, you multiply and you also add and subtract going from right to left. But in division, we actually divide from left to right. So we're going to say, first of all, before we do anything, I want to put a couple of things. I want to put a little multiplication X right here, right by the little pointy part. Very important. Please put that multiplication X there. All right. And for this first example, let me also draw columns for place value. Okay. For this first example, you don't always need to do this, but let me draw columns just for this first example because I want to make a point. Every digit inside the house, every digit in the dividend must have a digit above each digit or a placeholder above each digit on the roof of the house. That's very important, okay? Place value is important in division, just like it's important in addition, subtraction, and multiplication, okay? Place value is important. So for example, this is my ones place, my tens place, my hundreds place, and my thousands place. Place value still applies in division. Let's follow the steps. Divide is the first step, divide. What do? We're going to divide 5 into 6, okay? Another way to think of that is say, how many times does 5 go into 6? Or you could say, how many times can you subtract 5 from 6? And some of you are saying, wait, what do you mean? Mr. Barbier, wait, this is division, not subtraction. Guess what? The definition of division is division is repeated subtraction. You didn't know that, right? Yes, that is the definition of division. Division is repeated subtraction. In other words, how many times can you take 5 away from 6? That's another way to think of division. And the answer to that question is what? Obviously, once, right? You can't take away 5 from 6 more than one time, right? So when we say step 1, division, divide, when we say how many times can 5 divide into 6, we're asking how many times can 5 be subtracted from 6? Because again, division is repeated subtraction. So we said the answer was 1. So I put the 1 right here, right above the 6 on the roof of the house. 5 divides into 6. Another way to say that is 5 goes into 6 once. That's my divide step. Now we multiply. Now watch the motion. The minute I put a number on the roof for my division step, I do this. Watch. 1 times 5, and I put the answer underneath the 6, right? 5 goes into 6 once, so 1 times 5 is 5. I put it underneath the 6. That's my multiply step. Now I subtract. I'm subtracting 6 minus 5, or you can say I'm subtracting 5 from 6. Please put the subtraction sign, okay, so that you know what operation you're performing. What is 6 take away 5? Okay, someone just said that's 1, Mr. Barbier. Yes, you are correct. That is 1. Okay? Now you might say, Mr. B, what's the check step? What's that about? This is a very important step, ladies and gentlemen. Pay attention. When you subtract and you get an answer, right? In this case, my answer is 1. The check step says to make sure that this number is less than the divisor. Let me say that again. The check step says that after you subtract, quickly say to yourself, is 1 less than 5? If the answer to that question is yes, then guess what that means? It means that you've done everything right so far. You didn't make any mistakes. Let me be more specific. It means that this number 1 up here is correct. Okay, I want to say that again so that you understand what I'm saying to you. If you subtract and this number is not less than 5, I want to make sure you understood what I'm saying here. It has to be less. It can't be equal. You might say, Mr. Barbie, what if you subtract and you get 5 on the dot? Is that good? No, it's not good. It has to be less than 5. It can't be equal to the divisor, and it can't be more than the divisor. The answer after you subtract must be less than the divisor. And if it is less than the divisor, that means the number you put up here is the correct number. But if it wasn't less than the divisor, it means that this number up here is too small. It has to be a higher number, meaning 1 is too small. It would have to be 2 or higher, right? Something higher than 1. All right, that's what the check step is all about. So please do the check step. It takes literally 2 seconds. Subtract. Is this less than this? Yes. Okay, move on. After check is what? B, bring down. What do we bring down? We bring down the next number, going from left to right. So we said that 5 goes into 6 once. 1 times 5 is 5. 6 minus 5 is 1. Check. 1 is less than 5. B, bring down. Watch me. Bring the 8 down. I'm going to draw an arrow. Please draw arrows. I like to see arrows. And the 8 will go next to the 1 to form the number 18. That's how this works. Okay, very simple, ladies and gentlemen, very simple. And now after bring down, we go back to step 1, which is division. Now, some of you are wondering, Mr. Barbier, am I going to go 5 into 8 once like we did with the 6? No, we're not. So let me explain what I mean, right? Let me explain what I mean. You start the problem by saying 5 goes into 6, right? You start it that way. You start by looking at the numbers inside the house when you begin the problem. But when you start bringing numbers down, ladies and gentlemen, now we're not going to say 5 into 8, 5 into, no. You say 5 goes into 18. How many times? The 8 came down, it joins with the 1, it forms the number 18, and now you say, okay, I'm going to divide 5 into 18, and now you count by 5s to see how many times 5 goes into 18 without going over. So count with me. Ready? Count with me. So we're going to count. You make sure you use your fingers, right? Count it out. We're going to say 5, 10, 15, wait, stop there, 15, because if you, after 15 is 20 and 18 is less than 20. Remember, we want to go as close to this number as possible without going over. That's the key, without going over. So 5 goes into 18. How many times? You said 5, 10, 15. How many times is that? 3 times, right? So I put the 3 on top of the 8 on the roof of the house. Okay, again, because 5 only can go into 18 3 times without going over. Now, let's remember the motion, right? We said 5 into 18 3 times. That's my divide step. Multiply step is next. So the minute you put a number on the roof, you immediately go like this. Watch. We put the 3 up here, and now I'm going to go 3. Remember, we're done with the 1. The 1 is done. We're on the 3 now. 3 times 5 is what? Okay, 15, and we put the 15 under the 18. Okay, it's that simple, all right? So let me show you that again. We said 5 goes into 18 3 times. The 3 goes on top of the 8 that we brought down. Now we say 3 times 5. We put the answer underneath the 18. So 3 times 5 is 15. We put it underneath the 18. And now after multiply, we subtract. Okay, someone tell me. Subtract the 1's column. 8 minus 5 is... Okay, someone just said, Mr. Barbier, that's 3. Very good. And now continue. 1 minus 1 is 0. Good. We don't have to put the 0. Okay, because 0 has no value. Just leave it out. After subtract is what? Let me hear someone say it. After subtract is what? What step is this? Okay, someone just said check. And how does it work again? Okay, good. Yes. I just heard someone say, well, Mr. Barbier, 3 is less than 5. That means that we did everything correct so far. That is right. That is right. That means that the 3 is the correct number to put up here, that it's not too small. 3 is the perfect number, okay? Because this 3 is less than 5. What happens after check? We bring down. Bring down what? Okay, someone just said, Mr. Barbier, we're going to bring in the next 3. Bring it down. Always draw an arrow so that you know what numbers you brought down already and you don't bring on the same number again. You see, by me drawing this arrow underneath the 8, I know that I already brought the 8 down, and I won't make the mistake of bringing down the 8 again by mistake. You see, arrows are guides. Use them. Use them. Okay, very important. Now, after bring down, what do? Follow the arrow, go back to divide. Okay, divide what? 5 into 33. Someone tell me, how many times is that? Count by 5s. Okay, I'm hearing somebody go 5, 10, 15. How many times without going over? 6 is right. So 6 goes here. Okay, remember, as soon as you put a number on the roof, you multiply. Okay, and as soon as you put a number on the roof, that's the divide step, we multiply. 6, follow me, 6 times 5. Answer goes here underneath the 33, which is what? What is 6 times 5? Someone just said 30. That's right. And now we what? Subtract, right? 3 minus 0, somebody? Good, is 3. 3 minus 3 is 0. Very good. Okay, quickly check. Don't forget, check. Is 3 less than 5? Yes, it is. So now after check, I can what? Bring down. I only have one more number to bring down. What is it? Someone just said 0. Yep. Now the 3 becomes a what? It becomes a 30. The 3 becomes a 30. And after bring down, follow your guide, go back to divide. Someone tell me before I say it. What are we dividing? We're dividing what into what? Good. Someone just said, Mr. Barbier, you're going to divide 5, the divisor, into 30. Okay, so we're going to count by 5s, right? Yes, we are. Count by 5s. 5, 10, 15, 20. Okay, how many times? Good. Someone just said 6 times. Correct. So the 6 goes up here. Remember, as soon as you put the number up here, multiply right away. So 6 times 5 is what? Okay, someone just said 30. Very good. We put the 30 underneath the 30. We subtract and we get, okay, someone just said 0. That's right. So in other words, in this problem, we have no remainder. The problem divides evenly. That's how we say that in math, right? When you divide, when you do long division and there's no remainder, we say the problem divided evenly. Evenly is the word, okay? So what's my answer? Good. It's what? 1,366. Done. It's that simple. Okay? It is that simple. Ladies and gentlemen, I promise you, the more you practice this, the more you practice these steps, it will be second nature to you. Okay? I promise you, but you have to put in the practice. You have to put in the practice. Let's look at one more problem. Number 2. Okay? First things first, we can't solve it this way. Let's solve it with division house, okay? So let's go right into it. Okay, and let's put the dividend, which is the number that comes first, inside the house. Okay, let's put the divisor, which is 4, outside the house. Now, ladies and gentlemen, if you are feeling courageous, you know what time it is, don't you? Pause the video, try this problem by yourself, but make sure, don't forget, I need my guide. I need my guide along the left side of the margin. What's the memory aid again? Somebody tell me, what's the memory aid? Okay, someone just said, Mr. Barbier, well, the 5 family members, right? What are they? Okay, dad, mom, sister, cousin, brother, right? What does it stand for math-wise? Very good. Divide, multiply, subtract, check, bring down. If you want to circle them, you can. If you don't want to circle them, just leave it like that, you can. And don't forget the repeat arrow. Okay? So ladies and gentlemen, now's that time, okay? Don't forget to put your multiplication X right here. And again, if you like to put the columns, you can. If you don't want to put the columns, you don't have to. Let's try, for this problem, leaving the columns out. But just knowing that we need a number on top of every digit in the dividend. Okay? If you want to put the columns, go ahead and put them. If you think you could do this without the columns, then you could leave the columns off. All right? Again, pause the video, go for it. Okay, I'm going to assume that you tried the problem. You're ready to see if your answer is right. Let's see. Now, folks, this problem is going to be different than the first one. Okay, you're going to see it's going to have a few differences. Let's go for it. Divide, step 1. We're going to go from left to right inside the house. Can 4 go into 1? Okay, someone just said, Mr. B, no. Right, it can't. Remember we said division is repeated subtraction. Can you take away 4 from 1? No, right? You can't take away 4 from 1. So since we can't take away 4 from 1, that means that 4 cannot divide into 1. So we need a placeholder 0 on top of the 1. Just like that. Now some of you are saying, wait a minute, you mean placeholders are necessary for division as well? Yes, they are. Yes, they are. But now what do? You're thinking maybe, well, now we go 4 into 2? No. Since 4 can't go into 1 because 1 is too small, we put the placeholder 0. And now we connect these two numbers to make it what? Okay, someone said 12. Exactly. And folks, here's the deal. We're going from left to right, so ignore every digit behind the 2. So for example, if this helps you do it, let me show you what I'm talking about. Start by covering the dividend with your finger. Cover the whole thing, okay? And then you reveal one digit at a time. Can 4 go into 1? Nope. Put the placeholder 0. Show the next number. Now we say, can 4 go into 12, right? Ignoring the digits behind the 2, okay? So that we just look at the 12. Tell me, how many times does 4 divide into 12? Okay, someone just said 3 times because you know your times tables. Very good. So we put the 3 on top of the 2 like this because that's my division step. Okay, remember, again, ignoring the rest of the numbers for now. Okay, that's how we do division always. Left to right, and we go one digit at a time. Okay, now after we put the number up here, again, get used to the motion, guys. The minute you put a number up here, then right away go boom, 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 answer right here, boom. Okay, say it for me, say it. Okay, good, let me hear you. 3 times 4, answer goes here. What's 3 times 4? Okay, someone just said 12. We put 12 underneath the 12, and we subtract, which is step 3. 2 minus 2, 0. 1 minus 1, 0. You could put double 0 if you want. I'm just going to put 1, 0 because I don't really need the other 0. Check, is 0 less than 4? Yes, it is. And after check, we bring down. Bring down the next number. What happens after bring down? We go back to step 1, divide. Now, here's a little bit of an issue. We're dividing 4 into 1, right? Because 0, 1 is the same thing as just 1. But what do you realize? Okay, someone just said it, Mr. Barbier, 4 can't go into 1, right? 4 is bigger than 1. What do I do? What do you do in that situation? Guess what we need again? That's right. We need another placeholder 0. Just like we put a placeholder 0 here because 4 couldn't go into 1, but 4 goes into 12 3 times. Well, guess what? Same situation. 4 can't go into 1. Placeholder 0. Okay? Over the 1 that we just brought down. And now we can just, now you might, hold on, before I say anything else, some of you might be saying, Mr. Barbier, but you said that the minute you put a number up here, you immediately multiply, right? So you said the minute we put the number up here, we go this number times this number and put the answer. I did say that, but guess what? When you put a placeholder 0, that's the exception to that rule, okay? Since this 0 is a placeholder, I could go 0 times 4 is 0, and then 1 minus 0 is 1, but notice something, I would get the same number I started with. So why bother doing that? It's extra work for no reason. So what you're gonna do is the minute you put a placeholder 0, you just bring down the next number right behind it. Okay? All right? Let me say that one more time. We brought the 1 down. 4 couldn't go into 1 because 1 was too small. We put the placeholder 0 and then bring down the next number right behind it. Okay? Now, after we bring down that next number, again, after bring down, goes back to divide. So 4 divides into 17 without going over how many times? Count by 4s, guys. 4, 8, 12. Someone just said it's 4 times, right? 4 goes into 17 4 times. Now let's multiply. 4 times 4 is what? What do I put right here? Good. It's 16. Good. After multiplication comes subtraction. 7 minus 6 is what? Okay, good. 1. 1 minus 1 is what? 0. Again, I can leave the 0 out. I don't have to put it. And now, look, check. Is 1 less than 4? Yes, it is. So that means everything is right so far. I didn't make any mistakes. And now I can bring down the 0. After bring down, we go back to divide, right? Divide what into what? Someone tell me. Okay, someone just said, Mr. B, you're going to divide 4 into 10. How many times? Okay, twice. The 2 goes up here. And now the minute I put this number up here, as long as it's not a placeholder 0, right? 2 is not a placeholder 0. I'm going to go 2, say it for me, times 4 is what? Okay, good. So we just said 8. And now we, what? After we multiply, we what? Subtract. So now let's put the subtraction symbol. Can I take away 8 from 0? No. So borrow from this 1, make it a 0. And what happens to this 0? Good, it becomes a 10. Okay, now we can subtract, can't we? 10 minus 8 is 2. 0 minus nothing is 0, so I don't have to put it. Check, don't forget to check. Is 2 less than 4? Yes, it is. That means that, again, the work that we've done is correct. And do we have any more numbers to bring down? No. As you can see, every number we brought down has an arrow, so which indicates that we've brought down every number and there's no more numbers behind the 0. So here's the question that I get asked all the time. Mr. Barbier, we have this left over, which is called a what again? It's called a remainder. We didn't get a remainder with the first example, but we have a remainder now. What do we do with it? Okay, ladies and gentlemen, in elementary school, you were taught to put a capital letter R and put 2, right? 3042 R for remainder 2. But we're not doing that at this stage, okay, of our education. That was elementary school math. At this stage, we're going to do something different. We're going to take this remainder and we're going to put a fraction bar next to our answer. So right now we have 3042, but we're going to have a fraction because of the remainder. And watch this. The remainder becomes the numerator of our fraction. Okay? Now you might say, Mr. Barbier, what's the denominator? Is it going to be 1, right? Because every whole number has a 1 underneath it. Not in this situation, we do not put 1. No. The denominator is going to be the divisor. Okay? Now, so you're saying, wait a minute, that's always how we do this? The answer is yes. When you divide whole numbers, the remainder becomes the numerator. Okay, don't forget that. This is the remainder. The remainder becomes the numerator of the fraction, and the divisor, the outside number, becomes the denominator of the fraction. But guess what, guys? It doesn't stop there, all right? It does not stop there, because you have to look at this fraction now and ask yourself, can it be reduced? Because in math, we reduce all fractions. So can 2/4 be reduced? Okay, you're right. The answer is yes, right? How do we reduce 2/4? Let me do it like maybe up here or something so that we don't, it doesn't mess up our work. Let's do it somewhere up here. So if I have 2/4 and I want to reduce it, let me zoom in a little bit. I have to find a common factor between 2 and 4. And that common factor is going to be, someone tell me? Yes, it is 2. So 2/4, right? I want to reduce it. 2 divided by 2 equals 1. And 4 divided by 2 equals 2. Very good, okay? So this work here tells me that I'm going to take the 2/4 and make it into 1/2. So my final answer is keep the whole number the same, 3042 and 1/2. That's how you do it. Okay, ladies and gentlemen, that's how you do it. So for every problem you get in your classwork and homework, I want you to do 2 things. One, if the problem divides evenly, then you're set. That's the answer. You're done. If the problem has a remainder, I want you to take the remainder and make it into a fraction The remainder goes on top, the divisor goes on the bottom, and if the fraction can be simplified, another word for that is reduced, you must reduce it and give me the final answer. All right, so now let's take a look. You have classwork in the form of 6 problems. Okay, this must be submitted to me on Google Classroom. So you must do these 6 problems. 1, 2, 3, 4, 5, 6. And guess what I did for you? I already told you in the directions, right? To use long division to find each quotient for each problem below. The problems in red will have remainders. Write the remainders in the form of a fraction. These 3 will divide evenly. No remainder. These 3 will have a remainder. Okay, so please do the remainder. Take care of the remainder the way I taught you, okay, in the form of a fraction, okay? So that's that. And then you also have homework problems, okay? You have homework problems, and those problems are to be done and submitted on Google Classroom as well. Okay, it's all on Google Classroom, all right? It's all on Google Classroom. So there it is, ladies and gentlemen, there it is, all right? So now you know how to do your long division, okay? Now, please use these steps, right? Have them written in your margin for every problem, and you'll do just fine, just fine. Okay, ladies and gentlemen, so there it is. There's the video. Keep being great because I know you are, and I want you to know that about yourself as well. Stay great, and I'll see you in the next video. Take care.